I'm Philip Alsop, editor of Data Center Solutions, which is a part of Angel Business Communications digitalization world media platform. And I'm delighted to welcome you to today's virtual roundtable, which is looking at data centers, the energy innovation opportunity. And today we're discussing what role the data industry should play in such a future. I'd like to thank our host, Enel-X, the energy transformation company, for bringing together the Roundtable initiative. And I'd also like to thank all of you who are joining us today. And of course, I'd like to thank our 5 panelists for giving of their time so generously. And as we start, I will ask the panelists if they could introduce themselves to you. And if we can start with Astrid, please.
My name is Astrid Wynne, and I am the current chair of the Data Center Alliance Sustainability Special Interest Group, which looks at all areas of sustainability in the data center industry. My background is as IT hardware provider. I'm also a sustainability lead for TechBuyer, which buys, refurbishes and sells data center IT hardware.
Lovely, thanks. And David?
I'm David Watkins. I'm Solutions Director at Virtus Data Centres. So we are a data centre owner-operator based in the UK. We will have 10 data centres live shortly, and my role is working within the sales team alongside our sales guys on new business, liaising that back into the operational side of the business. I used to be operations director previously at Virtus, and then looking after our biggest customers on an account management basis day to day.
Thanks. And Gary?
Good morning, good afternoon, or good evening, I guess, depending on when you're tuning in. My name is Gary Connolly, and I'm founder of Holston Ireland, a co-opetition of companies promoting Ireland for the optimum place for data. I was the world's worst COBOL programmer, which makes it easy for me to relate to a lot of people who have problems and talking to engineering type people. But I'm delighted to be here. I'm delighted to be talking about data and the effects that it has on the planet. So thank you so much for Enel, and thank you so much, Phil.
That's great. And finally, Andrew.
Hi, I'm Andrew Toa. I work for Enel-X, leading our customer insights team. We work with a range of industrial and commercial customers, including data center operators, typically globally, providing energy solutions such as strategic sourcing, risk management, implementation of demand-side response activities. I'm an engineer by background. Have in previous roles worked in the design of systems within data centers, so very interested to take part in this discussion today. Thank you.
Lovely. Well, thanks very much, panel. So if we can start with a bit of a, I suppose, a sort of what I call a half-term report. So clearly, data centers have already been addressing energy efficiency, sustainability issues. So I guess if we can come to each of you in turn, and perhaps we'll start with Astrid again, but how would you characterize what the data center industry has achieved to date in terms of, I say, addressing energy efficiency, sustainability, and I guess whether you want to give them a grade or just say where, do you think that progress is good, bad, indifferent? Yeah, so Astrid.
I wouldn't dare give anybody a grade. I think the data center industry is incredibly proactive in terms of renewable supply and energy efficiency. And I think that's probably spurred on by the fact that particularly energy efficiency is an operational thing and a sustainability thing. So it's in your business interest to be as efficient as possible. I think that historically there's been perhaps a focus on energy at the use phase, and in terms of energy coming into the building and how efficient that is in terms of what it's doing and how far it's working towards cooling the equipment. And I think now the narrative is slightly changing towards talking about what is the processing power that you're achieving for that energy that you're putting in. I think that's a really useful discussion. It started, we'll go into the details later perhaps, but Once you start looking at that, then you have an increased focus on the IT hardware. And I think there's some great work being done on developing ways of reusing and repurposing and internal refurbishment, which Google have been incredibly vocal about, in order to save materials and ultimately save on manufacturing costs in terms of carbon. So, you know, IT hardware is incredibly carbon expensive to produce, and it has a lot of critical raw materials in, which are in low or politically unstable supply. Trying to find answers to making that last as long as possible, I think, is a fairly new focus in the industry, but people are taking it very seriously. There are research projects that are going on around that, and I think that that will help the industry as a whole become more sustainable in its entirety, looking not only at what it's doing when it's using the energy and making that more efficient, but also the way in which it replenishes itself more sustainably.
Okay, thanks, Astrid. And I guess, well, David, we'll go to you. Perhaps say characterise. Obviously, you're the owner operator of a data center, but how would you characterise whether it's your own data centers achievements and or the industry more generally in terms of, you know, energy efficiency today?
I think Astrid's absolutely right in that we're leading the way, I would say, from an industry perspective, in no short amount we're due to the pressure that we're under from our own customers. On the IT side, just picking up on Astrid's point, over the last 30 years, the amount of energy to process a given amount of data is reduced by about 7 times due to the increase in power of processing. So the IT equipment itself is more efficient, which is a good thing. From a plant perspective, you see efficiency increases 15-16% since about 2014, and as I said at the start, predominantly, you know, this is being driven by the customer base of the data center, and it's not just the big hyperscale customers. Sustainability is a big focus now for a lot of our customers, and they expect it of us as providers. There's a lot of innovation, I think, as well. There's a lot of well-publicized innovation. Microsoft recently tested a hydrogen fuel cell as a backup power source as part of their commitment to get away from using diesel, which at the moment it's a proven technology. It works, but it's not in an available form to deploy it at the scale that these types of organizations use. But the more they drive at this stuff, I think the quicker the development of it will improve, and ultimately that's going to drive efficiencies in the data center, less energy usage, and an all-round benefit for the environment.
Thanks, David. And Gary, any thoughts on where the industry is, you know, right now in terms of what it's achieved?
I think context is so important, and when you consider right now that we're very much entering the meaty stage of the Industrial Revolution 4.0, the most important aspect of that is, if we look back and we look at the first Industrial Revolution, what was the catalyst for change? Steam. The catalyst for change in this Industrial Revolution is data. Where does that data reside? In a center. And that's why we have data centers. So when you then have a look, we've always had data centers. They were just called comms rooms, or they were called on-premise equipment rooms or wiring closets. So we've always had these centers distributed in their thousands among office blocks. So really what we need to look at, again, for context and trying to evaluate how far the industry has come. If you look at the International Energy Association, their recent reports, which highlighted over the last 10 years, to David's point, that compute power has increased by a time of 7.5. Transmission across the networks, data-wise, has increased by a time of 12.5%. And yet, gross energy usage is flat at 1%. And you say, well, how could that possibly be? Well, it happens because when you take all those comms rooms which are multiple 300 kilowatts that are using no and are very inefficient, and you consolidate them into customized, fit for purpose data centers, you drive in the efficiencies. So that's the first thing, the efficiencies by consolidation. But also, and it's often missed by the wider audience, in my opinion, there is two words in data center. There's center, which is where the servers reside, and there's the data, which is the reason for being. And when we look at what the data is doing for smart grids, smart thermostats, smart cars, fundamental reason for it, reduce energy, reduce carbon, reduce all forms of emissions. So when you actually aggregate that, you start then to see that the reason that any device is smart is because of data. So if data is being driven, so the net effect is actually the centers themselves, which, as we say, according to the IEA, is 1%, 0.25% of all emissions. When we do a ready reckoner, you probably find the centers and offset the good of reducing emissions the data is doing are probably very much in the green. So when we don't talk enough about the data, and that's why I just wanted to discuss it early on, the tangible, 10 years, and also then let's look at the data. And that's, one should be offset against the other. You know, you want to make bread, you got to grow corn.
Okay, no, thanks for that, Gary. And Andrew, any other sort of thoughts on where the industry happens to be right now?
I think I'd echo a lot of what's been said there. I think to date, the data center industry has done very well around energy efficiency. To Gary's point, you do see that in the data, despite this exponential growth in data workload, the actual energy consumption increase is quite modest, relatively speaking. As Gary outlined there. We feel, or certainly I feel, a lot of the low-hanging fruit around energy efficiency has already been taken now, be that through technology that's been deployed in colos, or right the way through to the efficient design of hyperscale data centers. So maybe the industry's at an inflection point now where it gets harder, right? And as we really focus in on zero carbon targets, both at the macro country level, and various corporates start to focus in on true net zero carbon targets. I think going forward it gets harder. The solutions required get more sophisticated, and it's going to require a lot more collaboration between data center operators, between solution providers, between the government entities and grid operators, and that's actually the motivation for today, really. That NLX invited the various people on this forum to come together and share ideas around this and look at how we can push forward boundaries going forwards.
Yeah, to that point, on the low-hanging fruit and what Gary was saying about centralizing data processing and achieving efficiency in that way, there's now evidence that on the IT hardware side, efficiency is actually decreasing at maximum level, and it's flattening off. Moore's law means that the inherent efficiency gains are flattening off at maximum level, and in low power mode they're actually becoming less efficient, and which means that you have to look at the way that servers are operating, but it also means you need to reevaluate the idea that just constantly refreshing with new hardware will be more efficient by default. And I think that's one area in which we've got to ask ourselves a load of questions and come together as an industry to reassess truths that were assumed to be, irrefutable, because technology changes, and so we need to constantly have these discussions to figure out what the best answer is going forward.
Okay, yeah, I think we'll come back and revisit that IT bit in a little while. But Gary, as you pointed out, there's data and center in the data bit. I mean, we're in the digital age where anything and everything is connected or will be in the future. So, I mean, are data centers entitled, put it the other way, to say, leave us alone if you want to use your smartphones and your iPads and have all your IoT? Just let us get on and serve your needs? Or are we as consumers entitled to say, we want all this data, but we also want you to be sustainable and environmentally aware, or is that unfair?
When you mention leave us alone, I don't think there's any sector in any industry or subsector that can say leave us alone with respect to our global challenge right now. Obviously, our short term is the COVID pandemic, but our longer term and much bigger challenge is going to be reducing the carbon output. So data in the centers is the solution. That's the first thing we should write down. The data in the centers is without question the greatest tool we have in our arsenal for measuring, monitoring, all IoT devices that you have at the edge, all AI algorithms that you have looking to reduce energy is just data by another name. So then we look at, well, we gotta keep the rain off the data. Effectively, that's what we need the centers for, to keep it off the rain. When we look at that, then we see they're new, which is great. Most of them are new. They can be built more efficiently. They can be built on learnings. But also when you consider that the ICT industry, which includes a lot of what the platforms that we're talking about here, are by far the largest corporate power purchasers, making actual renewable happen, that has to continue because that sets good trends. The other thing that's really interesting that I'm seeing, which is ultimately going to have much wider implications outside of the data center industry, is the operators of the centers are now starting to set really, really aggressive net zero targets to their subsupply. And I think this is what Astrid is also mentioning, to their subsupply. If I'm going to put a target on my back that I want to be net zero by 2030 or 20 whatever, I'm going to have to take responsibility for what they class as scopes of carbon, scope 1, 2, and 3. I'm going to take credit for yours. So I'm going to drive through ways of procurement, ways of operating, which you as a supplier to me are going to have to change. And of course, a lot of those supply chain people don't just work in the data industry. They work in the hospitality industry. They work in the retail industry. They work in the aviation industry. So that's going to be good practice, going to be driven down through the supply chain. And thirdly, then there's three groups that have to be satisfied now. And they are end users are expecting that not only are we going to start to see like a calorie counter on our devices, we're going to see a carbon counter. That's what they're looking for. That's what they expect. And that's what we hope to be able to deliver. The second one are your employees. These ICT companies are some of the largest employers on the planet. Some of them are walking off site. And then the third, and unfortunately, we still live in a global capitalistic system. The money has now turned. The money investing new criterias now are now investing in companies that demonstrate, not just talk about, demonstrate that they have carbon reduction at the core, not over at a ESG group, but the core of their networks. So ultimately, there's lots of different parts there. Ground force, it's groundswell coming up, the money working down. I think ultimately now it's about, that saying, when all's said and done, in my opinion, when all's said and done, let's get more done now than said. We know what the target is.
Okay, David, to that point, do you, as a owner operator, do you occasionally in a quiet moment feel a bit annoyed, that you're getting a bit of a shoeing environmentally, or not the industry generally, but you're being obliged to meet this ever-growing digital demand? Or do you think it's entirely right that the two go, sort of hand in hand into the future?
I think it's entirely right. And the one piece sort of Gary missed as well, and I would echo what he said, is government. Because on top of all the companies and everybody else, all governments now are making claims, and quite frankly, they're not going to do it on their own. Governments are only going to get to carbon neutrality if the people that live there run their businesses and carry out their lives in a way that's supplementary to that. I mean, it's back in the day, table stakes were things like certifications and data security and all that kind of stuff. That was what everybody was worried about. Now it's all about sustainability. And I think it's a good thing. You know, we have an opportunity. There are challenges. Astrid's absolutely right when she talks about the level of improvement. One of the things I'll always say to people when we're showing them around a data center is that ultimately you can't beat the physics. So, you know, there'll come a point you've got electricity turning into heat, and you've got to keep the building cool. And there are ways of doing that, and we get better at it as we build new buildings and all the rest of it. But if you take it down to its simplest form, that's what it's all about. So it's about maximizing how much of that IT you actually use, which is why, to Gary's earlier point about putting it in central locations at scale, is much more efficient than all of us having a PC whirring away in our desk at home. Also, if you're using a cloud-based service, to the utilization point that Astrid made, the guys that know how to run these things are going to be much more efficient than I would be if I was running my own IT estate. And it's that type of thing that we need to make sure. And I think it's a lot of this is about messaging. Historically, we've not been good. You know, we're an easy target of look how much energy you consume. But then, okay, yes, I would agree. You know, we are large energy consumers, but how much would we be using if we weren't here? And the answer is a lot more.
That's an interesting point. Astrid, I mean, the data center industry is often compared, I think, and as David's alluded to, unfairly with the travel industry. To me, they're completely different, because travel is optional. You know, we can all stay at home, as we clearly are now, and, you know, go on a holiday down the road. So that's an optional thing. Data centers are not optional, because I say, unless we're all going to give up all these devices, we have to have them. So how do you see that sort of the tension, or the partnership between, you know, digitalization and data centers?
Well, first, I think more about the data center industry as the oil industry. You know, if you compare it to the Industrial Revolution, data is the new oil. It's something that everybody uses to run every business, but the producers come under fire. And I see some links there. I think there's a misunderstanding perhaps about what we actually use data for. So a lot of people's understanding of data is that you think if you use social media, you think of sharing photographs, and you think, well, that's perhaps something that we could do without. And so people kind of have a go at the data center industry for facilitating that, which to an extent is valid, but data also facilitates all the sustainability actions that are coming. So the Ellen MacArthur Foundation is the thought leadership group for circular economy, for example. It talks about sharing platforms, it talks about smart manufacturing. There's a project going on at the University of Exeter called Circular 4.0, which is looking at real-time maintenance for jet engines and all sorts of stuff. All of that requires a huge amount of data. It's not going to happen unless that data is processed, and unless the machine learning takes place to develop the right algorithms, which also is like exponential rise in data usage. And then the UN Sustainability Development Goals, also each of the 17 mentions technology and information technology and data as a pathway towards making the world a fairer, better place. So I think that there's a hidden aspect of data, I guess, that maybe people should be more aware of. And then absolutely every industry should, you know, be called to account on how efficient it is in order to do things properly. And nobody's saying that's not the case. I think perhaps, you know, if we could talk about what the data is actually used for and what our end goal is with that, then we might be in a better place.
Yeah, Andrew, following up on that, I mean, the data, as you say, there's a lot of incredibly useful data, and Astrid, you know, referenced data being the new oil, but clearly as well, lots of people are holding on to everything just in case, because they're being told that, you know, with data analytics, big data, it'll be useful some stage in the future. So I know it's very difficult to start, I mean, you know, my wife takes 10 pictures of the dog at night and sends them to everyone else. Yeah, isn't this lovely? I mean, she really doesn't need to do that. So she's never going to be stopped. You know, there's not going to be a law saying you can't take pictures of animals and send them. But are we just going to accept that this data growth is, you know, frivolous as alongside the important stuff? Or are we going to at some stage somehow be able to educate folks that you can get rid of it? And even in a business environment, so I'll let you answer in a minute, but you know, we're storing it all in these huge data centers. It's a bit like stuff in the attic. 90% of it never gets used again. And then when you move house, you finally chuck it in a skip. Do we, you know, do we need to be more sophisticated in how we, yes, I suppose how, you know, how we grade the data and what we do with it?
Well, addressing the business side, what I find interesting listening to Astrid is within the energy industry, we're going through a digital revolution now, and we're faced with, you know, huge challenges of, you know, how do we move to more of a decentralized energy grid? How do we integrate large-scale renewables? Often renewables that have been brought onto the grid, driven by power purchase agreements. You know, themselves driven by data centers. So there's a real sort of circular consideration there. I think that the data center industry has a big role to play in helping the grid and the energy markets digitize and at a practical level, given that demand, helping the grid integrate these renewables. So I don't think the industry should be left alone. But also, I think the industry has a responsibility to not only you know, continue to innovate on how efficient the industry uses energy, but actually it has a role to play in helping to digitalize and helping to move the energy market itself forward. In terms of consumers, you know, and you know, should we be stopping the frivolous use of energy? I don't know, it's difficult because there's so many positive things that have come from, you know, technology innovation, and I'm personally in favor of allowing that innovation to push forward, and maybe a lighter touch in terms of you know, reducing the amount of data that we create and process. But it's difficult to turn that off completely because so many good things have come out of that. That will, you know, in time help us get to a more sustainable future, in my opinion.
I suppose there could be a driver in that if there's greater consumer awareness of the cost of data storage transfer and a willingness to sort of reduce your own data footprint, then software innovators could come in potentially and defrag people's systems. You know, they could put overlay programs to do that. Gary, sorry.
Yeah, sorry, Gary. You...
Oh yeah, I think all three other speakers have mentioned language at least once, and that's so important right now. The language that's used to educate isn't engineering language. We don't need petaflops, zettaflops, megawatts, and also that language, PUEs and stuff, to communicate with policymakers and people who were trying to teach of the benefits of data. And what frustrates me greatly in general is when I hear people talking about reaching out to the communities to teach them about the power of data and use that language, when really what we should be using, to exactly Astrid's point, is Netflix, contactless payments. The grid's been running on smart grids is data, smart cars, all of the things that people actually are consuming on a day-to-day basis. I have an Alexa here. She's my personal assistant. That's just data. You know, we need to change the narrative even when we're talking to people. And recently I commented that David Attenborough, one of the greatest men alive right now, and straight up has one conviction: to raise awareness of the state of the planet. And he joined Instagram recently and got 2 million people within 40 minutes. I changed it around. I said he joined a data center to save the planet, because Instagram is just a brand name for a data center. But unless you tell people that, you'll get policymakers and individuals and detractors, et cetera, constantly saying to me, we really are not sure about these data center things. We really think they're going to be replaced by the cloud. Now, when someone says that to you, you know we are losing. We are losing. So what we need to do, and we should make it our conviction, let's speak to people like they're technologically 4-year-olds. Let's talk to them about the pandemic. Let's give thanks to two groups. Well, there's so many to give thanks to now at the moment. The healthcare workers, without question, but the second invisible front line was the digital front line. The other essential workers that were keeping, let's call it for this, any form of normal. This call, this recording, this video is on Zoom. That's just a name for a data center. The children that were all working and schooling from home. Google Meets or Google Class, that's just a data center. This is the language that I think, it reminds me a little bit about the electrification of Ireland in the 40s, back in the, the detractors were there. We'll look back at this time and we'll say, can you believe a time when people were objecting to electrification? And the only compromise they came to was, okay, we'll electrify towns, but every house can only have one light bulb. That's where we are now. We're at that communication stage, and to me, it's about words, it's about communication, it's about language, and we all have one goal, and that's to reduce the temperatures of the planet. Either use the centers, which keep the rain off the servers, but more importantly, the value, as Astrid, David, and also Andrew have said, the value of the data. That's the magic. That's the oxygen.
So I mean, I'm always intrigued because on the telly you get Microsoft and Intel advertising their, latest, greatest, whatever. As you say, maybe the data center industry needs to start, taking advertising space and telling people all the things they're doing. We're going to move on now to that IT piece. So they're obviously more, dare I say, sophisticated in the marketing. But I think, Gary, you mentioned the PUE as a, as one of those sort of horrible, not, industry words. But we have to look at the one of the PUE. I always think, everyone seems to think, your data center is 1 point whatever. Does the data center have any role to play, I guess, in pushing back on the one with the IT folks? So I guess, Astrid, maybe that one you can start for us.
Okay, so I'll start with the research that's been done by members of the Data Center Alliance a few years ago, which started to look at the one and started to change the conversation a little bit and say, okay, well, taking cooling out of it, how much compute bang, how much processing power do you get for your energy buck? And that should be your energy efficiency metric. And they did a study on public sector data centers around Europe. And they came up with some startling statistics. So they found that in the data centers that they studied, 40% of the servers in these data centers consumed 66% of the energy in order to produce 7% of the computing power. So basically, by not managing your IT hardware properly, you're having this massive inefficiency where you're using over 60% of your power to give you 7% of your computing power. So the obvious answer is, right, well, we need to look at that and we need to develop ways in which we can make that more efficient. So you start by stripping out those inefficient servers and replacing them with fewer, more efficient servers. Since then, the conversation's moved on slightly to say, okay, well, what does that look like? Because if you start stripping things out continuously every 2 to 3 years and putting them even to recycling, then you're losing, or you're creating a huge amount of e-waste, and e-waste is notoriously difficult to recycle. You can't recover 100% of the materials. Some of the materials in there you can't recover at all with current recycling technologies. And when you've got people like Google saying that they have set up an in-house refurbishment system and they're reusing old equipment in their data centers, you kind of have to wonder if there isn't a more evolved way of dealing with IT hardware, which will balance, waste against efficiency. And that's where a lot of the current research is going into on the IT side of the data center question. So there's an international research project called Circular Economy Data Center Industry, which covers 4 countries. It covers the UK, Netherlands, France, and Germany. And it's trying to find out what's actually in these servers and how much waste that represents, how much carbon that represents in terms of manufacturing and supply chain. And then what the best solutions are for people who want to refresh their data centers. And there, we've just submitted a paper with the University of East London to the IEEE, where we're talking about the slowdown in Moore's law and the fact that you can refresh to a previous generation of server with the correct component level upgrades. Sorry, I'm getting techie. Which means that you can basically make old machines outperform the latest machine with the right upgrades. That's kind of like niche. I guess I'm talking about that because I know about it, and also because it potentially has lessons for the wider industry. Because what it's saying is 2 things. One is that assumptions that have been made previously may no longer be true. And so you need to constantly reanalyze your technology and keep asking questions about what the most efficient answer is. And the other thing is that there's a lot of information that we don't have when we're trying to find out carbon footprinting and how we make a pathway towards net zero. So for the materials side, just on the IT equipment, it's only recently that we've got some kind of idea about what that costs us. And servers are being researched at the moment because they're in the UK Design Directive and all these other pieces of policy. But there's an awful lot of other equipment that is contained in data centers. And I'm not sure how far we've got in researching that and developing data on that, developing proper benchmarking and understanding of what's going in there. So because if we have that understanding, we can start reducing it and we can start making more meaningful strides towards net zero because you're looking at the complete picture.
David, you run a data center. So when a client comes to you and say, we need this amount of space and these are the, you presumably have some idea of the kit they're going to use. I mean, do you push back at any stage and say, that's very power hungry? I mean, what level, I guess, of engagement do you have with your clients when it comes to the IT kit, their pros and cons? You just let them get on with it?
None at all. Our product offering is quite simple, really. It's space, power, cooling, and security. Now, we would ultimately encourage, of course, customers to use more efficient equipment and use it in the best way possible. But to be fair, no one has a better understanding of their business than the customer themselves. There is a commercial benefit for them, though, of course, because the less amount of power and space they take, it's going to cost them less to run it. So to fill a room full of, to use Astrid's example, and this is something very common in time gone by, where and public sector is probably a good illustration of it as well, where a lot of deployments are project based. So funding will be made available for a project. They would go and procure the equipment to run that project, put it wherever in their own data center or in someone else's. And when you're not getting that benefit, and this is of the ramping up the utilization, it's one of the reasons, I think, to be fair, that a lot of the cloud providers have been so successful, because they'll do all of this stuff virtually. So you still get all the benefit. Then the end user's not got the cost of the hardware in the first place, the ongoing software license costs. It's a pay-as-you-go type model. So we would be interested in not so much what they're going to deploy, but how they're going to do it. So we will be very hot on how it's deployed in terms of airflow management and all that kind of stuff. So that whatever they put in is run as efficiently as possible from an operational perspective. But I have no view within the servers of what their utilization figures are or how much compute they're getting out of that particular deployment. But the point about reuse is a good one. I'm sure the research that Astrid's referring to is Google did a lot of work on this with the Ellen MacArthur Foundation, and there was a pretty scary statistic that in 2017 the global demand for resources was roughly 1.7 times what we can support on the planet. So it's just not sustainable. You just can't keep digging stuff out of the ground, using it and throwing it away. We've got to get better, and they've approached that in a number of different ways. About refurbishment, as Astrid referred to, but also stuff such as the older stuff. If they can't reuse it themselves, there's a secondary market for that stuff. So it could go to the developing world, for example, for use there. So it might not meet the performance statistic that they need right now, but there might be somewhere where you can reuse that. So recycling is almost the last piece of the jigsaw, because you try and reuse it or refurb it beforehand, and that's and there's no reason why. There's a lot of, whilst a lot of the stuff the data center uses is more mechanical, there's still a lot of the similar components in there, circuit boards and controllers and all that kind of stuff. So that is something that we need to be aware of. And to Gary's point of earlier, we need to push that down onto our suppliers too.
And I guess obviously in a colo, as you say, you're not necessarily able to engage in terms of what your customers are going to use IT wise, but just move to Gary. In general, whether it's a hyperscaler or an enterprise data center, where the IT department is directly obviously related to the data center because it's in the same organization, do you think there is a need for closer collaboration between those two functions to address some of these energy efficiency issues?
I think just step back slightly, if I could, Phil, again, with my mandate of trying to keep things simple. For many of the listeners that may not be fully familiar with the depth, breadth, and diversity of data centers, I think the best thing for us to do at this moment is to compare it to the retail sector, which is what people understand. When I say to people, well, data centers, they're not all the same, in the same way as retail is not all the same. You say, how do you mean? You have IKEA. They design, build, operate, and sell their own products. You've got the guy that is basically, and he is, let's call him for the purpose of this discussion, a form of a hyperscale. He's in complete control of his full supply chain. He's in complete control of every aspect of the procurement. Then you go down the road and you go to the local Basingstoke center, which is a large complex, like a co-location facility, where the developer is like David, where he goes and he gets the big chunk of real estate and he breaks it down into smaller. And some of those guys take a big space or a small space or even a concession space. In his case, it will be a server space, a rack space, or a cage. So you can start to see, when you do research and we go out and we say numbers, we have to make sure that this type of data center gave us these results, because they're not all the same, in the same way as retail is not all the same. That's the first, just to simplify to an audience who doesn't that think they are all the same. It's very diverse. It's very different. The second, and answering directly to your question, do I think that these groups should come together? There's actually a third group that needs to be included, because when we talk about data centers, it's as if they're all, there's actually about 3 different industries in there. There's a property industry, think of hotels. There's a manco, management company, a property company, a propco, and an operational company. So when you look at a data center, somebody owns the building, somebody operates the building, and then ultimately somebody owns the racks and the servers. So you're crossing numerous boundaries. From IT is 2 groups, hardware and software. And we're getting more and more now where software.
I didn't understand that.
Sorry, my personal assistant is telling me she doesn't understand me. You're not the first to tell me that they do. You're not the first to tell me that I'm not making sense. But so what you have is when you're in control, where you're designing, building, operating, and even to Astrid's point, a lot of the larger platform companies don't buy servers. They buy printed circuit boards. They don't buy the housing, because the housing on a server is actually only to stop it getting beaten up in transit. If you don't need that, then what you have is you have a whole rack of servers that don't look like anything but multiple printed circuit boards. Because that's called the OCP, that's the Open Compute Platform, where you're actually trying to strip out all the unnecessaries. So, but that's only if you own, operate, and stand over the software that sits on the center. When you go into something like David, if I might say, he owns the whole building or the retail complex. He doesn't own pennies. He doesn't own or operate the, you know, the shops that are inside. It just shows you how much I shop. I can't even think of 2 names of shops. But it's a better analogy than this, all data centers are the same. In terms of what Astrid is talking about a lot of, this is starting now to come in the narrative of 11-year-olds, and it's called circular economy. They now in their schools are asking, when I pare my pencil and I have the off shavings, can that be put onto the flowers outside? So that's where we're actually looking at being more efficient in everything we do. Servers, taking off heat in Dublin, for instance, we've got a new prototype at the moment, taking low grade heat off a data center to put it into local district heating. But so there's a societal shift that has to take place where the low grade heat can be put into a district heating. All centers have waste heat, but if you don't have the other side of it that you can take it, then basically that's a missed opportunity. So I think for the purpose of not knowing the audience, but let's say it's a very large audience of different stakeholders, it's more complex than you might think to switch a switch and put everybody onto new, very efficient equipment, because they may have only bought it last week. They may have spent 5 million on hardware in their own premise, and then a new CEO comes in and say, I want it all in David's facility. So you have a more efficient facility, but they're not going to chuck out the kit. It's just, you know, we got to be mindful that it's expensive. We got to be mindful that we're in a transitionary phase or a hybrid phase in our existence on the planet, whether it's servers or whether it's cars. We're in this hybrid evolutionary phase. But data is our greatest tool.
Andrew, before we move on to the facility side, any thoughts on the IT part of the data center?
I was going to talk a little bit about, you know, in some of the more advanced hyperscale scenarios, we've seen that it's not just about the efficiency of data processing, but there's a time element to when you process data. And we've seen people start to, you know, shift data processing tasks, you know, to certain times of the day or even certain regions, where there is, for example, an abundance of renewables on a grid, but it's complex, right? And I think to Gary's point, knowing the audience and how, you know, what level of understanding is, I'll probably pause there, Phil. We can maybe come back to that if you think it's worth it.
Okay. No, that's kind of, I mean, we've got to move on, I think, if only for time, but facilities, I guess, I mean, that's, you know, data center facilities, that's what we're all familiar with. That, to most people, that is the data center. Traditional data centers, I guess, again, most people might understand that, but there's a lot of newer technologies coming in there. In terms of, say, the batteries, we're moving from lead acid to the lithium ion. People are talking about liquid cooling. Our friends at Microsoft, I think they, can't remember that was it project there where they dumped one in the sea and then they brought it back up, etc. That's fairly extreme liquid cooling, but obviously bringing liquid to servers inside a facility. And so, David, I guess in the time available, are you able to perhaps characterize some of these opportunities, and as an owner operator yourself, tell us a bit about, you know, what you're able or what looking at doing with them?
Yeah, sure. So Gary's point about trying to utilize waste heat is a good one. I think the way I'd summarize it is, like with most things, there's a bit of a horses for courses element around this. So I know a colleague of mine that runs a data center in the Nordics where district heating systems have been in place for many years. So I remember him describing it to me once as using a kilowatt twice. So they use the energy to drive the servers, and then they take the heat, which is a waste product effectively of using that server, and then using that heat to put into the local district heating system, which is not something that's very prevalent in the UK. But we look at that. We do things on our own data centers where we try and use waste heat for driving heat pumps to heat the people part of the building. There's not many places in the data center that need heating, but the offices is one of them. It tends to be quite warm everywhere else. So that's one example. You touched on batteries. There's a shift at the moment from, as you say, from lead acid to lithium. The only note of caution I would add on the lithium side is lithium is a there's an amount of it on the planet. There's a big demand for it at the moment with the move to electric vehicles, etc. So we'll have to see how we go on that. I personally can see a future where you'll use certain types in one application and different types in another. Providing you use them properly, then there's no real need for that. Again, geography drives technology. So we used an indirect air solution in our second data center, which is very environmentally friendly. My colleagues who are in sister companies of ours in Asia would struggle with that technology just based on where they are because of the humidity in the air, and it's just not viable. So it's about looking at where you're deploying and looking at where you're going. UPSs, as they develop, are becoming far more intelligent. We use a model in our center that actually does look at load management, so you could kind of compare that to the server piece to a degree, where what the UPS will do is it will look at what the demand is. It's a modular system, so in simple terms, it's made up of blocks of power, and so let's imagine it can do 1,000 kilowatts. If the demand going through at any one time is say 300 kilowatts, it will put some of those power modules to sleep in order to reduce the inefficiency that you get when you're driving power through a UPS, which means that we can get a power efficiency up in the high 90s, which is a good way of doing it. There are some new developments on the cooling side. So there's immersion cooling, which you've referred to, where now there's some slight challenges with this. So this is where you're actually putting the servers in the bath to use it, but don't try it at home. Water and electricity, not a good mix, but this is a mix of a dielectric fluid effectively. So it's an oil of some form. But the thing to remember with this stuff, and it does look very impressive and it is very efficient, but ultimately there's still waste heat from it. So you're still going to need something outside in terms of some sort of chilling device to deal with that heat that's coming out. There was a recent document published by NTT, I think it was, where they have developed a new gas to use in DX cooling, which is it's CFC and HFC free. So DX cooling has been, a direct expansion cooling has been around for a long time, but you need a gas for it. And again, with the environmental question, not ideal. But this uses a a gas that's CFC and HFC free, and you can operate it at low pressure, which means you need less energy to operate it, and that was successfully demonstrated recently. So there's lots of stuff going on. Fuel cells, again, as we touched on briefly earlier, and so I think it's all there, but it's about developing this technology in order to be able to use it at the scale that you use it from. And just to give you an example of that, this fuel cell test that Microsoft were publishing recently, they ran 250 kilowatts of load off of this fuel cell deployment. But to give you an idea of size, a standby generator is probably about the size of a shipping container, just to make it easy. This fuel cell deployment was about the size of 2 of those and was doing 250 kilowatts, whereas a diesel generator, albeit it runs on diesel, of the same physical footprint, can probably do 6 megawatts. So multiple amount of power for that. So but the demand and the focus on it is only going to accelerate the development, I think. So there's, we're doing what we can. But then the thing that everyone needs to remember is one of the other reasons that people will use a data center is for the resilience. So they want to make sure, the way I would always describe it to people when I talk about it is, just think of it as a very well connected fridge. So when you go and buy your new fridge, you bring it home and you plug it in, and you never turn it off, because if you do turn it off, the food that's inside it goes off and lots of people get annoyed. And that's kind of what happened. That's a data center in a nutshell, but in a very simple analogy.
And just quickly to follow up with yourself, liquid cooling, I'd naively, when everyone talking about it, thought it was just a case of, eventually it'll replace air cooling, but it would appear that our favorite word may be hybrid, hybrid everything at the moment, but hybrid cooling is the future. So a lot of servers, because they're not necessarily operating at the high performance level, may never need liquid cooling, but a certain percentage performing the...
Yeah, absolutely. I mean, we're working on an opportunity with another company at the moment for some high performance compute, where, so to give you an idea in simple terms, most enterprise customers will probably be operating their racks with typically 5 kilowatts of load approximately in a rack. Hyperscalers will push that up to probably around 10 on their kind of standard deployment. In this high performing compute that we're looking at the moment, that's 250 per rack. So it's up in the kind of supercomputer territory. Now, to do that, you cannot cool that with air. So this uses liquid cooling in a way where we bring the water into the room, and then there's plumbing that goes around each rack to keep the rack at the right temperature. And that's a very niche and a very bespoke deployment. But again, to your point, it's that horses for courses thing. You use what's best for the application that you need.
Brilliant. I mean, that's a comprehensive round. Other, I don't know. I mean, Gary, any thoughts? Anything to add to David's talked about?
I think it's a great saying, and it's been around for forever. And the future's already here. It's just not evenly distributed, right? So when you talk about some of the stuff David had spoke about in terms of fuel cells, that's the way that diesel generators will be replaced when it's commercialized. The second stage is, and we see it already, is that smart grids in general would be wonderful if we had loads of wind blowing on and offshore and solar and stuff, but effectively we need some form of on demand. So what we're starting to see now is hydrogen is becoming, green hydrogen for the curtailment is becoming a very, well, it won't be this decade, but possibly within the next 2 decades will become a very viable form of gas that will be augmenting the smart grids. I'm sure Andrew has comments on that. But I think fundamentally where we are right now, and David, you've said it very clearly, you cannot beat science. You cannot manipulate science. It is what it is. And whilst currently society is still using electrons as its fundamental form of storing, forwarding, computing data, we are always going to be in this state of too much heat coming off too many processors and too many redundant servers. So when I say that the future is already here, it's not just evenly distributed. The next space race for NVIDIA, Intel, and AMD is for photonic microprocessors, not run on electricity at all, run on photons. You bring that then through to the next phase of storage, and Microsoft are the leaders in this, where we are now starting to see genuinely commercialized, real hologram storage. And also, not to be confused by the emotive word DNA, but synthetic DNA. Synthetic DNA is the end point for petaflops, zettabytes of data that's hosted on a sugar cube. And that is ultimately where we have to go. This sort of holy grail of trying to tweak the one and tweak is just playing around with the miles per gallon on your new car. Let's get rid of the miles per gallon, period.
That's
so therefore,
Sorry, I'm just wondering. Sorry.
So that's where we're going to. That should be our desire. Where if you ever feel a fiber optic cable that comes over the Atlantic that has 20,000 DVDs per millisecond, it's as cold as the water. There's no heat coming off it. That same technology that goes into the router, that goes into the backplane, needs to be transitioned across, and this is the space age for AMD and people like that. And that needs to be brought into the server so that we can transition away from the utilization and dependence on electrons, or to David's point, the science of electrons.
So Astrid, obviously.
I just had a question. I mean, yes, I understand what you're saying about protons and the lack of heat, but how do you make a proton? What materials do you need to create that current?
Well, there's two issues here. Firstly is the design, build, and operation. Well, the design and build has a certain carbon footprint. Would you agree?
Yeah.
Right. So obviously the biggest thing that we need to sort out there is the concrete on the center, right? Are we talking just carbon or are we talking data?
No, I'm interested. I've never heard of proton generation as a form of energy. So I'm just trying to figure out how you generate.
No, it's not the form of energy. It's the form of medium to get compute and storage. It's not energy.
Right. Okay.
So it's to reduce right down the amount of energy that's needed. Of course, you're still going to probably need a plug with an electron, but it could be 80 to 1,000 times less because you don't require it to cool down. If you think that you've got a photonic backplane with no heat, you don't need any cooling down of your center. Your point X disappears.
But the one's still there.
The one's still there, but it's nothing like what it was because the backplanes, the CPUs, and the storage and the SSDs is run on a photonic backplane. You don't have any energy. There's no electricity traversing. If you have a look at the microprocessor next holy grail, it's all about photonic microprocessors.
Okay.
That's the ultimate. David will have a problem because if he charges his clients based on energy space per given, he's going to have to change his metric back to space again, David.
Yeah, exactly. Yeah, put the space price up. Exactly.
And before we move on, Andrew, whether to that particular point or just more generally on the facility side?
Well, I think if we consider, data centers requiring, electricity for, for at least some time into the future, the innovation for me, is not just in the efficient use of electricity, but also in the way in which the data center interacts with the grid and the level of flexibility that data centers actually have. So data centers are actually one of the few industries with high levels of resilience and the ability to change the amount of electricity that they take from the grid, indeed come completely off grid. That's driven from a requirement to be resilient. But actually, if we look at the grid itself and the transition it's going through, with the huge deployment of renewables that's happening in virtually every deregulated energy market worldwide, it's becoming increasingly difficult to balance these renewables. And of course, they are by their nature, solar and wind themselves are intermittent. So I think data centers actually have, you know, a big opportunity and a big role to play in assisting, you know, the grid in being balanced. But that itself can also be part of a resilience strategy for the data center. So where we've worked with DC operators, in my experience, who have participated in demand response schemes, it's helped them to, well, firstly, be more aware of grid problems. As you know, as the grid operators become aware that there is a challenge on the grid, it's giving DC operators foresight into that. But it's also helping to finesse some of the testing strategies on the DC side. So I see a lot of innovation there. You know, innovation around use of existing equipment that sits within that power supply chain on a data center, and the ability for the data centers to just be a little bit more flexible in energy usage. Obviously, there's barriers, right? I mean, data centers, like, understandably prioritize their customers and their operations, and that's all about maintaining uptime. And there are barriers with anything that you know, is perceived to be a challenge to uptime. So I don't think it's straightforward by any means, but I do think as we look to the future and innovation around electricity usage within data centers, I think you know, it's not just about efficiency, but I think we'll see a lot of changes to the way data centers you know, operate with the grid and respond to the grid through demand response and the like.
I think the key point, just to add to that though, is around the future of technology, because increasingly emissions is becoming a real key point for data centers. And so we have huge diesel generator fleets, and we have restrictions around, you know, when and how we can use that, and predominantly we're able to do so because they are standby by name and standby by nature, and we live in a country with a pretty stable grid, which is good, unlike in other parts of the world where perhaps they use the generators more than they would the grid supply. So if there was a sustainable alternative to diesel at scale, then 100%, then you know, that would be a thing that data centers would do. But right now you're kind of betwixt and between, because you're on the one hand you're helping stabilize the grid, which is a good thing. On the other hand, then there's someone else saying, look at all those diesel emissions going up into the atmosphere, which is not good.
Isn't it interesting, David? We're all teaching and learning at different levels, because there's certain parts of Europe at the moment are quite happy to allow diesel generators be part of planning, but won't even consider a fuel cell because hydrogen is connected with it. Therefore, that's perceived as quite volatile. But go ahead with your diesel generators.
Yeah, that is it. And yeah, go figure. Oh. Yeah.
So we're all learning. We're going through. Again, it's important to put context for the viewers on this. The amount of data that we'll have in 2030 as a percentage of today is 6%. We've 6% now of the centers and the data that we'll have in 2030. We've got 25 billion things kicking off data now. We'll have 1 trillion by the end of this decade. And we haven't mentioned it, thank goodness, but really the data center industry by the end of this decade will look like a Russian doll. You'll have real big mother ones for a continent, right the way through to what we would call a data center on every corner of every street. And that is the data centers. That's why I was trying to say it's like retail. And when you aggregate at the end of the decade, we won't be talking about the energy usage of the centers that we're now talking about, the 10, 20, 30, 40, 50, 60, 100, 200 megawatts. The discussion will be thousands, maybe hundreds of thousands of 20 kilowatt ones that are on every corner of every street. It'll just move. So that's the data center industry. It's not just one. It's not just, think about it like retail, right down to the dude that sells the peanuts outside of Kensington Tube Station. He's in retail, but he's very different to Marks and Spencer's, right?
I mean, that neatly takes us on to, I guess, renewable energy. I mean, the industry is talked about a lot, and a lot of data centers say they get renewable energy. Obviously, it all goes down the same grid with non-renewable energy, so it's intriguing. You know, you can't actually see the green electricity arrive at your data center, but your supplier assures you that it's coming from a renewable source. But you know, whether it's wind or solar, people have alluded already to the fact that they're maybe not the most reliable. The National Grid the other week, I think, issued a warning because there had been no wind for a few days, that there were potentially going to be supply issues. So renewable energy, Astrid, where are we at, I guess, and what is possible and or desirable? And I appreciate, obviously, if you're in Scandinavia or Iceland, your idea of renewable energy might be completely different from, you know, us in London or Dublin or somewhere else.
The renewable energy mix in the UK is reasonably high at the minute, according to some reports. It's already at like 60%, some reports say. I'm not sure about the data on that. My problem with renewables is that, in a sense, you're potentially shifting a materials problem onto another big batch of infrastructure. So you look at wind turbines, huge amount of metals in there, which are environmentally costly to produce. Even without that, you've got critical raw materials inside the coatings, which will be impossible to recover. So they're non-recyclable. And then the alternatives to those, because everybody knows they're in short supply, are other critical raw materials. So in terms of the amount of materials that we have on the planet to cover these renewable generators, it's debatable whether they're actually going to be there or not, logic suggests. And I think that people kind of shift the conversation over to, oh, it'll all be renewable, it'll all be fantastic, without actually considering how we're going to build all this stuff in the first place. And that's a problem. I mean, if you talk to people inside sustainability meetings, they'll tell you there's not enough lithium on the planet to supply our car fleet if we all went to lithium cars. That's just in the UK. And then you're looking at those in other supplies as well, in batteries, blah, 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 blah. Is it going to be there? France has a high proportion of renewable supply, or a very low proportion of carbon. That's because they rely on nuclear. And that's a very tainted conversation in other parts of the world. So I don't know the exact stats on that, but for those reasons, I just think that maybe that conversation needs addressing by people who are actually experiencing it. Because even if you sit on, sorry, I'm going to go off piece now, but if you sit on climate change coalition meetings, they say we're going to have net zero by this date. We know where our carbon spend is. It's here, here, and here. Let's all insulate our houses. And they're not actually addressing what the data tells you is the core points. Like, and in a lot of cases, it's transport. There are no concrete targets against that. It's like people are making these big statements, but they don't actually have a roadmap of how we're going to get there. So sorry, that's not very helpful.
No, that's
the record piece. And then you guys have been in the industry a lot longer than me. Maybe you can come up with a more positive slant on that.
So yeah, Andrew, on the renewable side, what do you see? I mean, maybe I'm caricaturing it, but everyone was planting trees to offset carbon, and then they're getting a little bit of wind power. Is it no? Sorry, I'm just saying, is that sort of tokenism, and what is achieved more ultimately with renewables, or will it always be a sort of peripheral, something to tick on the corporate report, but never reliable enough to David's point? Resilience is vital, so you can never rely on wind power to power your data center.
Firstly, there are different ways to procure renewable energy, and each goes with maybe a different level of credibility in the claim to renewables. But I mean, if we think about power purchase agreements, obviously the data center industry has been a big proponent in power purchase agreements. If you look at any of the stats globally, often the top off takers Usually, a large majority of the top off takers are, IT companies and data center operators. I think we have to just maybe take a step back and think of what technologies large-scale renewables have displaced. And in the UK and Ireland, we've got some really good news stories there. A significant level of decarbonisation of the grid, displaced coal almost entirely in the UK. Between gas and the level of renewables that we've got, our grid is relatively clean. It could be cleaner, and obviously renewables create challenges around the intermittency and flexibility and balancing. But I think right now where we're at, they're an important part of the mix to getting us to net zero carbon. And I think that's probably the way we, typically if I think of the experiences I have, these large corporates, these large data center operators, they're all seriously committing now to really stringent net zero carbon targets. It very quickly becomes a global discussion, and it gets very complex really quickly. We talked earlier in the conversation about technology advancements. We talked about advancements in IT, but if you're a global sustainability lead, a data center operator, where do you start, right? And I think the reality is it's about developing a roadmap, developing pathways to get to that carbon target. It's not an either-or discussion. It's not to say you do a power purchase agreement or you do, you focus on efficiency, behind the meter. The reality is it has to be a multi-pronged approach. It has to be a combination of those solutions. Realistically, it's going to take time to get to a point. Gary mentioned moving to photonic data processing. That's not happening in the next 10 years, I don't think, right? So a power purchase agreement, it can be thought of as almost like a bridging technology to get to where we need to be. And I know that will open up discussions around the intrinsic carbon associated with renewable generation to Astrid's point. But I do think they have a very important a piece to play to get to net zero carbon. I think it's happening. I think data center operators have been to an extent real drivers in the certainly corporate renewable space. I think the next frontier is really helping the grid balance all that renewables through demand response, participation through storage, etc. But I think in the longer term, yes, we need other things as well to supplement certainly wind and solar.
Yep, Gary, come in.
Phil, I've listened to an awful lot of people way more intelligent than I and in much more powerful positions than I to take a view on this. And from what I deduce from all of the discussions and all of the scientific papers is that there's probably three things that we need to do as global citizens to get ourselves out of this hole of climate increases in temperature. Stop burning things, right? First. Stop eating certain things. Second. And the most contentious one, but probably one that is very important, we need to stop having that extra child as global citizens. They are the three things that will always emerge as the three things. We need to stop burning fuel, driving places, making electricity, etc. But we need to find an alternative. We need to look at how we produce our food, how we distribute our food, how we consume our food. And the third thing is a whole different issue. Okay, and it'll be different all over the world. But effectively, they're the three things. So if we are going to talk about we need to stop burning things, if we in the absence of a viable alternative, we must look at what the earth has given us: wind, sun, and wave, for the transitionary technologies to give us the electrons that we need for all forms of society including data centers. Makes sense. Or go down the nuclear route. But in the absence of those, what else is there, right? Okay. With regard to innovation and technology, I might come from this as a different, I was a terrible COBOL programmer, I said, 35 years ago, but I've been in the IT business, data business, and we moved, every 10 months we move on its head. So we're used to change, we're used to evolution. No disrespect to anybody here or in the audience from the electricity distribution, but since Edison and Tesla created the whole fundamentals of electricity, it has changed a bit, but it hasn't changed every 10 months. So they're going to see a whole on its flipping on its head. You even see it with the engineers coming with the passion that want to be in the electrical industry. They don't want a job for life. They want to change the way it was done. They want to do smart, distributed, prosumers, all this type of stuff. So that whole industry, and Andrew, I'm sure you would back that up. You don't want to be the same dude anymore with a job for 30 years, right? So that's the wonderful thing. The third thing that I'd say is that we tend to, as humans, overestimate what we can achieve in 3 years and underestimate what we achieve in 10. And that's only my own experience in IT. And the final thing is, when I came into the data industry, data was held on hard disks, big, chunky, 50 megawatts on your desk, hard disks, 50 megawatts. I now have a phone here with 516 gigabits or whatever. So everything is changing fundamentally and everything is possible. But in the absence of an alternative, viable alternative, the most obvious thing is to harness what we've got, bearing in mind what Astrid is saying, making sure that we utilize what we can. But in the alternative, we must do the best we can with the information we have at hand at this moment in time. But I don't think we stop just because of something that may happen.
Okay, David, again, I come to you, owner operator, renewable energy. I'm guessing a lot of customers like the idea of you saying, oh yes, we use renewable energy, but does it go deeper than that sort of cosmetic thing in terms of your commitment or the industry's overall commitment to coming up with sustainable resources, I guess?
We've been using fully renewable energy for multiple years. So we have a contract with a company based or they're owned by Statkraft in Norway, and it's purely renewable, so it's wind, solar and tidal. But as you say, it comes into the grid and then you get onto the whole balancing thing and all the rest of it. Governments are pushing this. Last year last year it was about 20% of the UK fuel mix was from renewable sources. It will probably be 30% by the end of this year. This summer, it got to 47% in June, which is the highest it's ever been. 36 was the previous record for it. So the developments there, the government have got their own targets to hit, which they're just not going to be able to do unless they use renewable energy. What we are starting to see though is at the moment, the energy contracts that we have are kind of the best we can do because they're certified. There's an audit trail as to where that energy is coming from, etc. But to your point about the grid, if you wanted to, wholeheartedly demonstrate the energy you're using, you need to be right next door to the place that's generating it. And those two things are kind of like that. That you can't. We can't go and build all our data centers on the coast so it's right by the wind farm. Solar energy has a problem, particularly at night, when we're trying to generate stuff, obviously. So it's about coming up, to Gary's point, with that mix of do the best you can with what you got. But we are seeing more pressure from customers as to, okay, so this renewable energy, how does it work, where do you get it from, etc. But our options, as Gary very well described there, are limited right now. We made a point, and we have a customer, a large corporate customer that's a global organization, and one of the things that they pushed really, really hard was, you don't use nuclear, do you, in your renewable energy? And we don't. But that's a key thing for them, because whilst it's obviously carbon neutral, they view what it is, rather than carbon neutral, as far worse than a bit of carbon.
And I mean, time is moving on, so I'm conscious of that. Maybe we can try and summarize a bit. Do you think we need I guess, the ongoing evolution, or are we needing a bit more of a revolution to address some of these points? We're talking about sustainability. I know targets, people are setting targets, whether it's governments or there was a data center company the other day, I got a release saying they wanted to be carbon neutral by 2040, which I have to say my immediate reaction was, wow, that's 20 years away. That's quite a long way. But
I think,
sorry.
So I was going to say, I think the challenges with this is, it's about coming back to what we were talking about right at the start. It's about working together. My fear in a target-based scenario is, who's setting the target and what understanding have they got of what you're doing already. And I've seen in the very recent couple of weeks talks about targets that are being set, these are dreaded. So PUE was never ever designed as a performance benchmark. It was a metric that you could demonstrate how you use your energy on site, and it's become a big stick to beat people with as to what it is and how you get there. And there were talks legislative level about stuff that might be coming, where they're going to say, every data center's got to have a PUE of less than whatever it might be. But the numbers are just so arbitrary. Some of the figures that were being discussed are very challenging to achieve in certain locations, depending where you are geographically, with the technology we have available today. But that's because it's in my opinion, it's come from someone that doesn't have the understanding, of if we were left to set our own targets, we're doing it anyway. We're being driven by the customers. Everybody's on board with this about being green, and I don't think we need we need legislation to make us doing it. We're doing it anyway.
Okay, yeah, I mean,
you don't want to run the risk that it could be decided by someone who thinks you're going to be replaced by the cloud. You want to be careful of that.
Yeah.
Yes, I'm not sure it's an apocryphal conversation or not, but I know someone in the data center industry, a government minister, said, "What are you going to do with all the data centers when everything goes to the cloud?" Not quite understanding that concept. So yes.
Well, I think what that people need to understand, to use a simple analogy, as Gary's been doing very well today, is that if the data centers are the cloud, then we're the sky. They've got it's got to be somewhere. You've got to be able to get it out there. The cloud, it's not magic. It's just a virtual place that you store data, but it's got to live somewhere for real.
Maybe a thought that we use sometimes is that there's different types of cloud. There's stratus, there's cumulus. There's also, they're all part of the cloud, but they're just different clouds, huh?
Yeah, exactly.
Yeah, no, I always thought the cloud was an unfortunate, because it rains in a cloud as well, which is perhaps not a nice thought if you're in a cloud. But to conclude, then maybe, I mean, a bit of a sort of fantasy situation. If there's a Ministry for Data Centers, you're in charge. To David's point, do we need legislation? Do we allow the industry to self-regulate? And more importantly, what would be the one or two key focuses, initiatives that each of you would look at? So Astrid, maybe you can kick us off on that, please.
If I was a Minister of Data Centres, I would invite experts from every area of the industry to come in and give evidence, and then I would collect together a series of best practice guides, because it's quite a diverse industry, as everybody has been talking about the past however many minutes. And you can't be experts in everything. And the key to understanding all this and making progress is collaboration and understanding from each area of expertise. So that's where I would focus it. I would focus it on intelligence gathering with the overarching aim of making it more sustainable.
Okay, Andrew, can you give us thoughts as the Minister for Data Centres?
Well, if I was the Minister for Data Centres, the first person I think I would talk to is the Minister for Energy. I think I would be looking to foster far stronger collaboration between the data centre and the energy industries. I mean, partly answering your previous question, I don't think it's the data centre industry that needs to go through a revolution. I go back to the start. I think the data centre industry has done very well to date, but the energy industry does need to go through somewhat of a revolution. And I think there's a strong link, both in terms of the significant energy usage that we expect to come from data centers, but also, the opportunities that come from, data center operators to help the grid innovate and digitalize. So I'm not in favor of regulation or sticks, very much carrots, but I think we need to foster somehow a much stronger collaboration and interaction between data centers and the energy grid operators and the energy industry as a whole.
Thank you. Gary, as the Minister, what would you be up to?
I'd do an analogy and I'd say, let's take overall society as a car and the data center is a spark plug, okay? And the overall objective of the car, in analogy, is to get to net zero by a date or get to a destination by a date. And what role does the center play in us getting to reduce the carbon overhead of that society? You take the gross energy, for instance, that the center is using, and you look at the offsets that the data is saving in all the other industries. It's been said by all the speakers. Yeah. You don't just bring in energy people. You don't just bring in the center operators. You bring in the software people. You bring in the people that are using the smart cities. You look at the people who are using the data and you say, okay, I now get why I need the centers. It's because it's the oxygen of the data that's giving the tools to all these other people to reduce carbon. It's the spark plug in the engine. Whereas at the moment they're looking at it so incessantly that they can't see the wood for the trees. It's just looking down in this center without having any knowledge of its societal relevance. And I said earlier, or maybe I didn't, I was on some other talk. I said, this is a time right now as we come to the end of the year, in my opinion, to give thanks. Yeah. And the two groups are the healthcare workers, frontline, and the digital frontline workers. And when you start with that discussion, you say, why would I give thanks to the digital frontline workers? Because anything that's the normal right now is because of them. Anything. So therefore, the discussion has to go from center to data to societal. And we will look back in 10 years, no, 50 years, and we will laugh about these discussions about servers and about centers the same way as we laugh now thinking of substations for electricity. Has anybody, Andrew, in your line of work, had any discussions about substations recently?
Not that I can recall.
It was the talk of the town 50 years ago. You're getting a substation. Oh, it's going to give us all cancer. It's just evolution.
Thank you, Gary. And David, the final go at being the Minister for Data Centres.
Well, I suppose the easy answer would be I refer to the answers my honourable colleagues gave a moment ago. But
or you could refuse to be interviewed, I suppose.
Yeah, I could refuse to be interviewed. Yeah, just send out ridiculous tweets for the rest of the day. What I would do, I think, is I would. I think, whilst I would not drive towards regulation, as I said before, one thing I would insist on is that each data center company had a sustainability program. We're all doing it anyway, but it's the world's best kept secret a lot of the time. And the pressure that the industry is often under from an energy perspective, I think could be alleviated to a degree by just tell people what you do. You know, we are doing that all the time. And I think the other thing to do, and we've seen some benefit in this recently, is very often within the data center world, you'll hear people talk about mission critical. You know, it's an age old phrase. You know, we can't do without it, etc. Yeah, but we're not the only people that are doing mission critical things. I'd like to think if I was in an operating theatre with you know, my chest cracked open, I'd like to be pretty confident that the power wasn't going to go off during that time. You know, and so that there's lots of clever people in other industries approaching similar problems, but maybe in a slightly different way. And maybe we need to do more of talking to other people, to Gary's analogy, and sharing that type of knowledge, and it will be for the benefit of everybody.
Okay, I mean, the debate, as far as I'm concerned, has been brilliant. Really enjoyed listening to you all, and we've had a great range of opinions. So thank you very much. Thanks, Astrid, David, Andrew, and Gary. Obviously, thanks to our listeners. Thanks to NLX for sponsoring this. Just a couple of notes of housekeeping. We are currently running a survey around some of the issues we've discussed, with NLX host in Ireland and the DCA and ourselves DCS. So I think once I have stopped talking, you will find the web URL come up so you can go and follow the survey. And the other thing, if you've got any questions based on what you've heard today, there will be an email address again, Piers, which you can email to follow up on any of these conversations. So once again, thanks to the panel, and thanks to you folks for tuning in. Thanks again. Bye-bye.